Okay, Chapter 4, Section 7, using the quadratic formula. Basically, the quadratic formula is a formula that mathematicians derive by completing the square so that you can find the x-intercepts of a quadratic. Okay, basically the quadratic means it has to be degree 2. So given a quadratic where you have an a, b, and c as coefficients, you can use this formula to solve for the x-intercepts. You can use other methods as well. You can use completing the square to find the vertex form. You can use factoring. There's other methods. However, this is always going to work. So if you're taking any sort of test and you need to find the x-intercepts, you can use the quadratic formula no matter what, and it will work. So let's go ahead and do that. Solve the following quadratic using the quadratic formula. X squared plus 10x equals negative 25. Well, there is a problem with this one because we have to set it equal to 0 in order to have our a, b, and c value. So I'm going to add 25 to both sides first in order to get them in order. So I have x squared plus 10x plus 25 equals 0. Next, I have to determine what a, b, and c are. So a equals coefficient is 1, b equals coefficient is 10, c equals constant of 25. Now I want to go ahead and use those values and plug them into my quadratic formula. However, I've learned in the past that if you do that right away, you are more likely to make mistakes by just plugging it in. So break it down. Go ahead and do the discriminant first, b squared minus 4ac. So the first step, I'm going to go ahead and solve b squared minus 4ac, which is 10 squared minus 4 times a, which is 1, times 25, which is c. Then go ahead, then simplify your discriminant. So I have 100 minus 100, which is 0. What does that tell me? If the discriminant is 0, that tells me I'm going to have one x-intercept for this quadratic. One x-intercept. Let's find out what that x-intercept is by then plugging that 0 in for the discriminant and solving the quadratic formula. So I have negative b, which is negative 10, plus or minus the square root, plug in your 0 for the discriminant, over 2 times 1. The square root of 0 is 0, so we're just left with negative 10 divided by 2, which is negative 5. That is my one x-intercept, negative 5, 0. Let's try another one. 3x squared equals 2 times the quantity 2x plus 1. I'm going to distribute so I can get my a, b, and c. So I have 3x squared equals 4x plus 2. And now I have to get everything on one side, so I'm going to subtract 4x and subtract 2. These are going to cancel. I'm left with 0 on this side, and then I have 3x squared minus 4x minus 2. And I do that so that I can find my a, b, and c values. My a value is going to be 3, my b value is negative 4, and my c value is negative 2. Go ahead and find the value of your discriminant, b squared minus 4ac. B is negative 4, so negative 4 squared minus 4 times 3 times negative 2. 16 minus 12 times negative 2. 16 plus 24, which is 40. Once you have your discriminant, go ahead and plug 40 in for your discriminant and solve your quadratic equation. So I have negative b, negative negative 4, plus or minus the square root of 40, all over 2 times 3. So I have 4 plus or minus square root of 40 over 6. And the way I'm going to get my two x-intercepts are the plus and minus. I'm going to take 4 plus the square root of 40 over 6 and 4 minus the square root of 40 over 6. And I'm going to ask for decimal answers for these and not fraction or simplified radicals. So we're going to go ahead and plug those into Desmos. I'm going to pull up Desmos here. And I'm going to go ahead and do it. 4 plus the square root of 40 over 6, which gives me 1.7207. I'm going to go ahead and round that to the nearest hundredth, so 1.72 for the first one. That's my first x-intercept. My second one, I just have to change that to a minus, and I get negative 0.39. We'll round to the nearest hundredth. And those are your two x-intercepts, using the quadratic formula and then a calculator to find the decimal. Solve the following using quadratic formula. So we're going to go ahead and simplify this one first so we know our values of a, b, and c. So I have 2x squared minus 2x equals 3. And I'm going to subtract 3 from both sides. So I have 2x squared minus 2x minus 3 equals 0, so that I can find the values for a, b, and c. A is 2, b is negative 2, and c is negative 3. B squared minus 4ac, find the value of the discriminant. Negative 2 squared minus 4 times 2 times negative 3. So I have 4 minus 8 times negative 3, which is negative 24. So 4 plus 24 is 28. That tells me I'm going to have two x-intercepts because it's a positive number. My discriminant is positive. Let's find what they are by plugging it into the quadratic formula. X equals negative b, so negative negative 2, plus or minus the square root of my discriminant, 28, over 2 times 2, which is a. So I have 2 plus or minus the square root of 28 over 4. And now I'm going to plug it in to my 2 plus the square root of 28 over 4 and 2 minus the square root of 28 over 4. Two plus the square root of 28 over 4, 1.82, and then 2 minus the square root of 28 over 4, negative 0.82. There's your two x-intercepts. Now this is number 1 on your worksheet. We'll do an example of your worksheet. A says find the value of the discriminant. B says describe the nature of the roots, which just means tell me how many x-intercepts or roots I'm going to have. And C, solve the equation using the quadratic formula and then round to the nearest hundredth. So part A, find the value of the discriminant. Well, I need A, B, and C first. A is 1, B is negative 9, C is 14. B squared minus 4AC is the discriminant. Negative 9 squared minus 4 times 1 times 14. 81 minus 56 is 25. So part B, describe the nature of the roots, means since it's a positive number, I'm going to have two x-intercepts, or two roots. Then part C, what are those roots? Well, I'm going to use my quadratic formula. X equals negative b, so negative negative 9, plus or minus the square root of your discriminant, all over 2 times 1a. Now this one, 25 is a perfect square, so this one we can take negative negative 9, which is 9, plus or minus 5 over 2. 9 plus 5 over 2 is my first x-intercept, and 9 minus 5 over 2 is my second one. So this is 14 divided by 2, which is 7. 4 over 2, which is 2. There they are, 7, 0, and 2, 0. So that's number 1. Number 2 looks a little different. And if you notice, number 2 can be, we could solve this by factoring, take out a greatest common factor, but we're not going to for this one. We're just going to practice doing the quadratic formula. So I'm going to subtract 3r to get it equal to 0. So I have r squared minus 3r equals 0. Part A asks for the value to discriminant. So my A value is 1. My B value is negative 3. And since I don't have a C value, it's going to be 0. So I am going to go ahead and do B squared minus 4AC, which is the discriminant. I have negative 3 squared minus 4 times 1 times 0. 9 minus 0 is 9. What does that tell me about this quadratic? It means I'm going to have 2 x-intercepts. And since it's a perfect square, that means that my x-intercepts are actually going to be whole numbers. They're not, most likely they're not going to be fractions, or they're going to be easier to solve. So part C, I'm going to use a quadratic formula. X equals negative b, so negative negative 3 plus or minus the square root of my discriminant, which is 9, over 2 times 1. So I have 3 plus or minus the square root of 9 is 3 over 2. So I have 3 plus 3 over 2 and 3 minus 3 over 2. 6 divided by 2, which is 3. It's my first one. 0 divided by 2 is 0, my second one. Let's try one more. This one, x squared minus 1/2 x plus 1/16 equals 0. Part A says find the value of the discriminant. So I need my A, B, and C. A is 1, B is negative 1/2, and C is 1/16. So B squared minus 4AC. I have negative 1/2 squared minus 4 times 1 times 1/16. So this gives me 1/4 minus 1/4, which is 0. What does that tell me about my quadratic? That means I'm going to have one x-intercept since my discriminant is 0. Part C, I'm going to find that one x-intercept. X equals negative b, so negative negative 1/2 plus or minus the square root of 0 all over 2 times 1. Negative negative 1/2 plus or minus 0 is just positive 1/2 over 2. When you're dividing, you just multiply by the reciprocal. So I have 1/2 times 1/2, which is 1/4.